Welcome to Surveying and Geospatial Insights. Today we're covering LiDAR Calibration Basics, what it means to align your sensor, GNSS and IMU, so every point lands where it should. Whether you're collecting from a drone, aircraft, or mobile mapping rig, solid calibration is what turns a dense point cloud into data you can trust for measurement and mapping. LiDAR calibration starts with understanding the difference between intrinsic and extrinsic parameters. Intrinsic settings govern how the sensor measures ranges and angles, while extrinsic parameters define the sensor's position and orientation relative to the platform. Keeping these terms clear helps teams diagnose errors and document adjustments consistently. Accurate lever arm offsets are essential because small mistakes in the measured distance between the LiDAR and the GNSS IMU reference point propagate into every point. Measuring the offsets with repeatable methods and clear reference marks reduces systematic shifts in the resulting point cloud. Careful documentation makes future maintenance and reinstallation far less risky. Boresight calibration aligns the LiDAR's roll, pitch, and yaw to the IMU frame so that the point cloud is geometrically consistent. Even tiny angular misalignments can show up as double edges, sloped walls, or mismatched strips. A controlled calibration workflow helps isolate these angles and produce defensible alignment values. Range bias and timing offsets affect where points land along the direction of travel and across surfaces. A small latency between the LiDAR, GNSS, and IMU can create a long track stretching or compression that looks like a subtle shear in features. Verifying time synchronization and checking for consistent range offsets improves geometric fidelity. Good calibration depends on choosing targets and scenes that expose specific error modes. Flat plains, building facades, poles and well-defined edges make it easier to see angular errors, scale issues, and misregistration. Designing a calibration site with intentional geometry speeds, troubleshooting, and improves repeatability. Strip alignment checks compare overlapping passes to reveal systematic offsets and drift. Looking at differences on hard surfaces and vertical structures helps separate navigation issues from sensor misalignment. Consistent quality control across multiple runs builds confidence that calibration parameters hold under normal operations. The GNSS or IMU solution quality sets the ceiling for achievable LiDAR accuracy. Poor satellite geometry, multipath, or IMU initialization issues can masquerade as calibration problems in the point cloud. Monitoring navigation metrics and keeping a clean trajectory workflow prevents chasing the wrong root cause. Environmental conditions can bias calibration results if they aren't considered. Temperature changes, vibrations, and mounting flex can subtly alter sensor alignment, especially on vehicles and aircraft. Capturing calibration data under representative operating conditions improves how well parameters transfer to production work. Point cloud inspection should include quantitative checks, not only visual review. Fitting planes, checking residuals to control surfaces, and analyzing cross-sections provides measurable evidence of calibration performance. These metrics support repeatable acceptance criteria for both field crews and office processing. Calibration is more reliable when treated as a documented, repeatable process. Recording configuration files firmware versions, mounting photos and calibration dates, supports traceability, and simplifies audits or troubleshooting. A clear change log also helps teams understand when recalibration is warranted after hardware adjustments. That's a practical look at LiDAR Calibration Basics and why small alignment errors can create big positional and elevation differences across a project. The key is to treat calibration as a repeatable workflow. Verify sensor offsets, validate with check surfaces and control, and document your results so the data remains defensible. How do you confirm your system is calibrated before you commit to full production? Thanks for watching Surveying and Geospatial Insights.